Let's see which methods we have in information systems research. For that, let's first see what the role of information systems research is. You see it here depicted in the middle between the environment and the knowledge base. The environment, these are the people, the organizations, the technologies out there in the wild. This is what we want to study, what we want to contribute to. On the other hand side, you see the knowledge base. These are the foundations, the theories, frameworks, constructs and the like, and all the methodologies one can use. And IIS research is positioned in the middle. So we draw the business and societal needs from the environment, and we draw applicable knowledge from the knowledge base, and then we try to develop and build new theories, new artifacts, and we assess them, we justify them, we evaluate them by applying scientific methods, and we use these methods to refine what we develop, what we build, the theories and the artifacts. And with this, we contribute to both the environment and the knowledge base. With regards to the environment, there's especially the question around the relevance of our research. With regard to the knowledge base, there's a question of the rigor of our research. And the central role in this, highlighted in yellow on that slide, is for methodologies which we use to justify or to evaluate our theories and artifacts. So this is the role of methods, of methodologies. Let's see which different methodologies we typically have in information systems research. What you see here is a simple 2x2 grid differentiating the degree of formalization and the paradigm. On the degree of formalization, we see the quantitative numeric or the qualitative linguistic part. So this combination of terms qualitative, quantitative, it roughly differentiates between the predominantly numerical on the upper side or the predominantly linguistical on the lower end of the graph facts. With respect to the method, this is a degree of formalization of the object being researched, of the technology, the relationships, the person, or whatever the object being researched is. And furthermore, beyond this object and its formalization, it's important to what extent the method itself is formalized. That is, to what extent the underlying rule system specifies the cognitive processes and the individual steps involved in the method. That's the one dimension, that's the degree of formalization. Regarding the paradigm, we have the behavioral and we have the design-oriented perspectives on information systems research. The behavioral science paradigm has its roots in the natural science. It seeks to develop theories and explain or predict organizational and human phenomena surrounding the design, the implementation, the management, or the use of information systems. The design-oriented part, on the other hand, has its roots in engineering. It seeks to create innovation. It develops artifacts that support the design, implementation, management, and use of information systems. So in a very stylized manner, you could say that the behavioral side tries to understand the world as it is, and the design-oriented side tries to change the world by improving artifacts, by introducing new artifacts. Now that we know this 2x2 grid, we can use it to place the 20 commonly used methods in information systems research along these two different dimensions, the degree of formalization and the paradigm. And let us start with the most prominent, the most widely used method in information systems research, surveys. Structured surveys are on the behavioral paradigm side, and they are rather quantitative, rather numeric. Structured surveys are research that uses predefined and structured questionnaires to capture data from individuals. Typically nowadays these are online surveys, but it can also be mailed in pen and paper surveys, or it could even be fully structured in-person interviews following a structured questionnaire. So this differentiates the structured survey from what we typically consider interviews, which would typically be in-depth or semi-structured interviews. But let's continue with the structured surveys, as that's the most commonly used method. These structured surveys are behavioral and rather quantitative in the sense of eliciting mainly numerical responses, which are subsequently analyzed by statistical methods like regression analysis, factor analysis, structural equation modeling, and the like. So you have a very formalized way of eliciting the data, you have quantitative data, you have statistical methods analyzing that. And as said before, with a survey you try to understand the world as it is today, for example, the perception of individuals operating in organizations with technology or the like. Somewhat comparable to structured surveys are laboratory experiment, one of the other top 5 methods used. In an experiment, you have an artificial constructed environment here in a lab environment. So traditionally this was a computer pool or individual cubicles where people work on computer terminals, and you have a rather controlled, strict environment where you manipulate only very few things, for example, the instructions or the interface of a computer program, and then observe behavior by participants. Nowadays we have also online experiments where, rather than the controlled physical lab setting, people sit at home or at work at the desk and participate in a structured, constructed environment, but now in an online environment. These experiments are more design-oriented than surveys, as the artificial lab environment or the artificial online environment, for example, the software application or the context, is designed by the researcher. The next method is mathematic modeling. So this is about having an analytical model, for example, an optimization model, which is developed for the phenomenon of the study. And then inferences from this model, for example, the optima in an optimization model or sensitivities to different input parameters or so on, are derived analytically from the model itself. The general approach here is deductive, and the inference is then following directly from the set of assumptions you place in there. And because it's so deductive, we are on the design-oriented part, the design-oriented paradigm, but it's really highly quantitative in the sense of being formal mathematical with an analytical solution to the mathematical problem. Now, after having been rather quantitative on these first three methods I introduced, the next one is qualitative. It's a case study method. It's a study of a single phenomenon, for example, an application, a technology, or a decision, in an organization or in another context. And this case study typically happens over a logical time frame, so it has some time dimension and then it studies a single phenomenon. And there are single case studies, for example, analyzing the introduction of a new system in one specific organization. But there are also multiple case studies, for example, analyzing the introduction of the same class of system across multiple, like 2, 3, 4 or so organizations. Not to the extent that we would move into the quantitative part and that we would try to quantify the outcomes, but in having comparisons between the different qualitative cases in a qualitative multiple case study. And these case studies analyze individual or organizational behavior as it naturally occurs. Thus, they are on the behavioral paradigm side, and as I said before, they are rather qualitative. To round up this set of the top 5 methodologies in information system research, there's a literature review. This is research that is based mainly on the review of existing literature in a rather qualitative analysis style. We'll come to more quantitative-oriented literature analysis later on. Now we're in the rather qualitative literature analysis for the moment. A literature review may develop a framework, it may develop a conceptual model, and it may draw on analysis procedures like types of content coding or the like from content analysis or from grounded theory. Such a literature review might, to some degree, quantify the frequency of occurrences or co-occurrence of codes, but the primary analysis procedure is qualitative. And these are the top 5 methodologies typically used. We increasingly often see mixed method research or multi-method research, which uses different methods within a single paper, a single article. If this is done, then we count the occurrence of one of the methods, either the primary or the secondary method here, in the frequencies of these different methods when saying that these are the top 5. But as frequently as I mentioned that these are the top 5, let's move on, because obviously there are more. So let's move on to ranks 6 to 10. So what we have next are qualitative interviews. These are semi-structured or in-depth interviews. They are a very common way to generate primary empirical data for qualitative analysis. Typically they are face-to-face. They might also be via video conference or via telephone or the like. But then the medium is not really the distinguishing feature between the qualitative interviews and the structured survey. It's rather that the structured survey, which we had before, is really structured and it tries to elicit numerical data. The qualitative interview is either semi-structured or in-depth, so it's way more free flow. The answers are basically free text answers, verbal answers typically, and you then later on try to code them to distill knowledge from it. Typically interviews are with individual experts, with key informants or with affected people. However, there are also group interviews and focus groups. And interviews are closely linked to other methodologies like case studies, which we already had, ethnography or grounded theory, which will appear on this chart later on. So sometimes it's a little different to distinguish whether qualitative interviews is a single standalone research method or whether it's part of other methods. Next, we have field research. This is a study of a single or multiple related processes, phenomena in a single or in multiple organizations or contexts. So that sounds pretty vague. To me, that is pretty vague. It's somewhat a summary of different research approaches, but then others distinguish it as individual standalone methodology. That's why I've put it on this chart as well. Moving one further on, we have the speculation or commentary. It sounds a little strange to consider that a research methodology, but yes, it might be a research methodology. It's research that derives from thinly supported arguments or opinions with little or no empirical evidence. They emerge from a low-structured process in which argumentative concepts are developed and discussed. They are strongly deductive in the analysis phase. That's why we place them on the paradigm side, on the design-oriented. And they are very qualitative and linguistic. That's why we put it on the very bottom of the chart to mark the bottom right-hand corner. I said these are low-structured processes. If it would be totally unstructured, then it wouldn't be a scientific methodology. But as soon as you get some structure in these commentaries, these speculations, then you might phrase it as a scientific methodology contributing to scientific knowledge. When we stick in the design-oriented paradigm, but now become more formalized, to close the gap between the speculation commentary on the qualitative side and the mathematical modeling on the quantitative side, then we have the framework development and conceptual modeling. So this is research that intends to develop a framework on a conceptual model, for example, a process model. This is a semi-formal method, not as formal as mathematical modeling, but more formal than pure argumentative, deductive analysis or speculations and commentaries. If we move to the top left corner of this 2x2 grid, then there we have secondary data. So there we talk about studies that utilize existing organizational or business data or other existing secondary data. For example, financial or accounting reports, archival data, digital trace data like log files or anything like that. So these studies oftentimes use advanced data analysis techniques from econometrics, from social network analysis, from machine learning or the like. Now we have the top 10 methodologies in information systems research. Where do I derive the knowledge from that these are the top 10? Well, there are from time to time studies who analyze a set of top journals in the information systems discipline and then look at the individual papers published there and they code which type of methodology is used there and then analyze their coding. So they get frequency information on these different methodologies also over time. And from that you can derive the market share of these different methodologies, if you want to phrase it like market share. So how frequently are they among articles in the top journals? And what we see is if we look at the top 5 methods, then these account for about 70% of the articles in the top journals. And the top 10, which we now saw, they account for about 90%. So they account for the majority of articles where you will find at least on one of these methods in most of the articles. But on the other hand, there are many others as well. So we'll continue with ranks 11 to 20, but I'll cut it a little shorter because they're less common. So next we have field experiments. They are closely related to laboratory experiments, but they are out there in the wild, oftentimes without the participants knowing that they are part of an experiment, which obviously poses challenges on the ethics of research, and it is difficult to conduct such field experiments. This is to some degree why they are rare. They are rather low on internal validity, so they are less controlled. It's less clear what happens in such a field experiment compared to a lab experiment. But on the other hand, they are high on external validity, so they are really close to the regular day-to-day life of people, the day-to-day use of technologies and organizations and the like. Next we have simulation. Like field experiments were closely related to lab experiments, simulation is closely related to mathematical modeling. It's from the start, from the set of assumptions and the formal model, basically the same as mathematical modeling, but you don't derive the solution, the optimum or whatever analytically, but via computer simulation. You could, for example, use a Monte Carlo simulation, an agent-based simulation, or the like. So as I said, it's close to mathematical modeling, but not deriving an analytical solution, but a simulation-based solution. Next, we have ethnography. On the qualitative side, somewhere in between behavioral and design-oriented research. Ethnography is a behavioral science method that generates findings through participatory observation in the immediate social environment of the object of study. So the difference to a case study lies in the very high scope, and that the researchers integrate really deeply into the studied social environment. If we stick with the qualitative methods, then we have grounded theory. This is a behaviorally oriented approach. It aims at inductive extraction of new theories through intensive observation of the object of investigation in the field. So this is closely related to case studies and ethnography. The various procedures for coding and evaluating the predominantly qualitative data, which might also arise from interviews, as I said before, are precisely specified. Thus, it is one of the more formal approaches to qualitative research. So remember before, when I introduced this 2x2 grid, I said that on the degree of formalization, it's on the one hand about the degree of formalization of the object in the study, but then also about the method and how formalized, how specified the method is. And grounded theory is among the more formalized qualitative methods. That's why it's placed on the degree of formalization higher than, for example, the qualitative interviews or the case study. Next, we have taxonomy development, and with this round up the set of behavioral qualitative research methods. Taxonomy development is the process of developing taxonomies, of developing classification schemes, and you develop them inductively, deductively, or both. The result is then rather a basic type of theory, a theory for analysis, not for prediction, explanation, or action or the like, but a theory for analysis, which is this classification scheme, which is the taxonomy. Pretty much at the center of this 2x2 grid is the meta-analysis. Before I talked about literature reviews as rather qualitative approaches to summarize literature. Now, meta-analysis is one of the quantitative approaches to summarize literature. It starts with a structured search for literature on quantitative empirical evidence regarding a specific phenomenon. A meta-analysis then extracts the empirical findings. Most importantly, it extracts the effect sizes from the primary literature, combines them statistically, and thereby produces an aggregate assessment of the effect. So if you have 5 or 10 or 100 different studies on the same phenomenon, and they all report effect sizes, for example, all report correlation coefficients or regression coefficients, then you can pool these across the different studies. You don't need the primary data for that, but you take the data reported in an article, and you pool this data and thereby get a better estimate of the effect and the significance of the effect. That's a meta-analysis. The other rather quantitative approach to literature, which I want to present here, is bibliometry. Bibliometry studies academic literature itself. So not what's studied and reported in the literature, but the literature itself. Examples include studying topic trends or methodological trends in a stream of literature in a discipline over time. So, for example, if you quantify the research methods used in top journals and information systems research, and then quantify that and present time trends and the like, then this is a kind of bibliometry. And there you can use co-author networks to understand the driving forces behind a field of research. You might understand the topic trends over time, the methodologies used or the like. So while literature review was the qualitative analysis of extant literature, meta-analysis and bibliometry are two quantitative approaches to literature analysis. Next is reference modeling. Reference modeling has a special role among the conceptual models. It's closely related to the framework development and conceptual models. But the goal of a reference model is to represent a planned or an optimized reality that is a reference model. So it's a special type of model compared to the more general conceptual modeling. Prototyping is the next method I want to briefly introduce. It's a method with the most tangible design reference among all the methods I present to you here. A quickly available, executable, preliminary version of an application system is developed and evaluated. Typical variants of such prototypes are user interface prototypes, which analyze user interfaces and how users interact with these, or functional prototypes, whose focus is on a proof of concept of the function. So finally, the last method of the top 20 methods used in IS research is action research, also action design research. It's design-oriented and it provides for the joint solution of a practical problem by a mixed group of scientists and practitioners. In this process, several cycles of analysis, action, and evaluation steps are run through. So it's an iterative process where practitioners and scientists jointly try to solve a real-world problem, but then also apply scientific methodology and scientific knowledge for solving this real-world problem. So this is a wide array of research methods. The upper left quadrant, the quantitative empirical behavioral studies, is strongest. It has the largest share among the studies in top IS journals. But there's not a one-size-fits-all method. I mean, for one, there are multiple of these quantitative behavioral research methods. But as you see from this overall grid, there are multiple other methods as well. There's no one-size-fits-all method. There's no silver bullet. And the challenge is to pick the best method or the best combination of methods if you talk about mixed method, multi-method research for a given research question and context. That's the one challenge. And the other challenge is to execute the method or the methods you use skillfully. And if you want to know more about how this grid is constructed and where you can read more, you find here the sources I rely on for presenting these different notes on how I adapted these different sources, how I merged them, and then some footnotes on what's in which of these methodologies. So there you find information where you can read more about all these different fascinating methodologies. So there you find information where you can dive deeper into these different methodologies, how they're used, how they're trending over time, and which topic areas they are related to.